In the last video, you ended up creating your very first asynchronous application, but unfortunately, we ended up asking more questions than we got answers to. We don't exactly know how async programming works, even though we've used it. My goal for you in this video is to understand why the program runs the way it does. For example, why does this 2-second delay not prevent the rest of the app from running? And why does a 0-second delay cause the function to be executed after finishing up prints to the screen? These are all questions we're going to answer in this video. This video is going to take you behind the scenes into what happens in V8 and Node when an async program runs. It's a little complex, which is why I recommend multiple viewings. I would watch it once now, I'd work through the weather app, and then I would watch it once again. When you come back to it after having played around with a lot of async programming, it's going to make a lot more sense. Now let's dive right into how this program runs. We're going to start with the basic example, then we'll move on to figuring out exactly what happens here. Here is example number 1. On the left, we have the code, in this case, a really basic synchronous example. And on the right, we have everything that happens behind the scenes. The call stack, our Node APIs, the callback queue, and the event loop. Now, if you've ever read an article or watched another video on how Node works, you most likely heard about one or more of these terms. In this video, we're going to be exploring how they all fit together to create a real-world working Node application. Now, for our example here, the first one, the synchronous one, all we need to worry about is the call stack. The call stack is part of V8, and for our synchronous example, it's the only thing that's going to run. We're not using any Node APIs, and we're not doing any asynchronous programming. The call stack is a really simple data structure that keeps track of program execution inside of V8. It keeps track of the functions currently executing and the statements that have fired. The call stack is a really simple data structure that can do two things. One, you can add something on the top of it, and two, you can remove the top item. That is all it can do. That means if there's an item right here and there's an item above it, you can't remove the bottom item. You have to remove the top item. If there's already two items and you want to add something onto it, it has to go on the top because that's how the call stack works. Think about it like a can of Pringles or a thing of tennis balls. If there's already an item in there and you drop one in, the item you just dropped in, it's not going to be the bottom item, it's going to be the top item. And you can't remove the bottom tennis ball from a can of tennis balls. You have to remove the one on top first. That's exactly how the call stack works. Now, when we start executing this program, the first thing that happens is Node runs the main function. The main function is that wrapper function we saw over in NodeMon that gets wrapped around all of our files when we run them through Node. In this case, by telling V8 to run the main function, we are starting the program. The first thing we do in the program is we create a variable x, setting it equal to 1. And that's the first statement that's going to run. Notice it comes in on top of main. Now this statement's going to run, creating the variable. Once it's done, we can remove it and move on to the next statement, where we make the variable y, which gets set equal to x, which is 1, plus 9. That means y is going to be equal to 10. Right here, we do that, and we move on to the next line. The next line is our console.log statement. Console.log is going to print y is 10 to the screen. We use template strings to inject the y variable right here. When we run this line, it gets popped on to the call stack, and once it's done, it gets removed. At this point, we've executed all of the statements inside of our program, and the program is almost ready to complete. The main function is still running, but since the function ends, that wrapper function, it implicitly returns, and when it returns, we remove main from the call stack, and the program is finished. At this point, our Node process is closed. Now, this is a really basic example using the call stack. We went into the main function and we moved line by line through the program. Before we get into an async example, I want to go over one that is slightly more complex. This is example 2. Here, we start off by defining an add function. The add function takes arguments a and b, it adds them together, storing that in a variable called total, and it returns total. Down below, we add up 3 and 8, which is 11, storing it in the res variable, then we print out the response. And that's it. Nothing synchronous is happening. Once again, we just need the call stack. The first thing that happens shouldn't surprise you. We execute the main function. This starts the program you see right here. Then we go ahead and run the first statement where we define the variable add. We're not actually executing the function, we're simply defining it. Right here, that gets added on to the call stack and we define add. The next line, Line 7, this is where we call add, storing the return value on the response variable. When you call a function, it gets added on top of the call stack. When you return from a function, it gets removed from the call stack. Right here, we're calling a function, so we're going to add onto the call stack, and we're going to start executing that function. As we know, when we added main, we started executing main. When we add, we start executing add. The first line inside of add sets the total variable equal to a plus b, which would be 11. Then we return from the function using return total. That's the next statement. And when this runs, add gets removed. So return total finishes, add gets removed, then we move on to the final line in the program, our console.log statement, where we print 11 to the screen. This is going to run, it's going to print 11 to the screen, it's going to finish, and now we're at the end of the main function, which gets removed from the stack when we implicitly return. And there we go. The second example of a program running through the V8 call stack. Now, so far we haven't used Node APIs, the callback queue, or the event loop. The next example, we're going to use all four. And right here we have our async example exactly as we wrote it in the last video. In this one, we are going to be using the call stack. We'll also be using the Node APIs, the callback queue, and the event loop. All four of these are going to come into play for our asynchronous program. Now, things are going to start off as you might expect. The first thing that happens is we run the main function by adding it onto the call stack. This tells V8 to kick off the code over here on the left. The first statement is really simple, a console.log statement that prints starting app to the screen. That runs right away, and we move on to the second statement. The second statement is where things start to get interesting. This is a call to set timeout, which is indeed a Node API. It's not available inside of V8. It's something that Node gives us access to. When we call it, we're actually registering the event callback pair over here. The event is simply to wait 2 seconds, and the callback is the function we provided, that first argument. When we call set timeout, it gets registered right over here. And now this statement is going to finish up, the call stack is going to move on, and the set timeout is going to start counting down. Just because the set timeout is counting down, it doesn't mean the call stack can't continue to do its job. The call stack can only run one thing at a time, but we can have events waiting to get processed even when the call stack is executing. Now the next statement that runs is the other call to set timeout. Here, we register a set timeout callback function with a delay of 0 milliseconds, and the exact same thing happens. It's a Node API, it's going to get registered over here, essentially saying, hey, after 0 seconds, go ahead and execute this callback. That gets registered, and the call stack removes that statement. Now at this point, let's go ahead and assume that set timeout, the one that has a 0-second delay, finishes. When it finishes, it's not going to get executed right away. It's going to take that callback and move it down into the callback queue. The callback queue is all of the callback functions that are ready to get fired. Right here, we move the function down into the callback queue. Now the callback queue is where our callback functions are going to wait. They need to wait for the call stack to be empty. When the call stack is empty, we can run the first function. If there's another function after it, we're going to have to wait for that first function to run before the second one does. And this is where the event loop comes into play. The event loop takes a look at the call stack. If the call stack is not empty, it doesn't do anything because it can't. There is nothing it can do. You can only run one thing at a time. If the call stack is empty, the event loop says, great, let's go ahead and see if there's anything to run. Right here, there is a callback function, but because we don't have an empty call stack, the event loop can't run it. So let's move on with the example. The next thing that happens is we run our console.log statement, which prints finishing up to the screen. This is the second thing that shows up in the terminal. This statement runs, our main function is complete, and it gets removed from the call stack. At this point, the event loop says, hey, I see that we have nothing in the call stack, and we do have something in the callback queue. So let's go ahead and run that callback function. It's going to take the callback and move it into the call stack. This means the function is executing. It's going to go ahead and run the first line, which is sitting right here on line 8, console.log, printing second set timeout to the screen. This is why second set timeout shows up after finishing up, because we can't run our callback until the call stack is complete. Since finishing up is part of the main function, it's always going to run before second set timeout. After our second set timeout statement finishes, the function is going to implicitly return and callback will get removed from the call stack. At this point, there's nothing in the call stack and nothing in the callback queue, but there is still something in our Node APIs. We still have an event listener registered. So the Node process is not yet complete. 2 seconds later, this event is going to fire and it's going to take that callback function and move it into the callback queue. It gets removed from the Node APIs and it gets added to the callback queue. At this point, the event loop is going to take a look at the call stack and see it's empty. Then it's going to take a quick look at the callback queue and see there is indeed something to run. What's it going to do? It's going to take that callback, add it onto the call stack, and start the process of executing it. This means we're going to run our once statement inside of callback. After that finishes, the callback function implicitly returns and our program is complete. This is exactly how our program ran. This illustrates how we're able to register our events using Node APIs and why when we use a set timeout of 0, the code doesn't run right away. It needs to go through the Node APIs and through the callback queue before it can ever execute on the call stack. Now, as I mentioned in the beginning of this video, the call stack, the Node APIs, the callback queue, and the event loop are pretty confusing topics. And a big reason they're confusing is because you never actually directly interact with them. They're happening behind the scenes. You're not calling the callback queue. You're not firing an event loop method to make these things work. This means you're not aware they exist until someone explains them to you. Now that you know a little bit about how our code executes behind the scenes, I want you to move on with the rest of the section and start creating that weather app that interacts with third-party APIs. When you're done with the weather app, come back and give this one a second viewing. These are topics that are really hard to grasp the first time around. By writing real asynchronous code, it's going to become a lot clearer how it works. Then when you come back and rewatch this, my hope is that it makes more sense. If you have any questions about how this works, please ask in the Q&A section. It's impossible to cover everything that happens, but I've tried to go through a few examples that illustrate how the call stack, Node APIs, the callback queue, and the event loop work. That is it for this one. I will see you next time where we start building out the weather application.